So this figure shows GDF15 and its importance as a signal, all the way from the beginning, from its production, through its transportation, to its receptor, to its signaling, to the effects. So what is GDF15? GDF15 is growth differentiation factor 15. It's a protein that is produced as the result of an injury within the body, or something that causes cellular stress. This can be tissue damage or on the body. It can also be something such as obesity, anything that really causes cellular stress in the body. That's this response. So once this cellular stress is recognized within the cells, it produces GDF15 and sends it out into the bloodstream. Now, um, once it's in the bloodstream, uh, GDF15 is going to be sent around until it reaches the brain, specifically the area posterior of the brain, the hindbrain. And now this is really important because this specific region is not across the blood-brain barrier. This allows GDF15 to be uh, perceived at the receptor faster and easier as it does not have to cross this barrier. And so its specific receptor is GFRAL. Now, when GDF15 binds to GFRAL, it can't do much alone. Thankfully, it's located here on the lipid raft, which has its co-receptor, RET, located on it. There are many other receptors that are located here. However, RET is what's really important. So when GDF15 binds to GFRAL, RET is able to come over and it is phosphorylated. This, in turn, activates the signaling or downstream signaling to occur and allows for GDF15 to actually take effect within the body. And so the overall effects of GDF15 or the signaling from it is the regulation of appetite, regulation of metabolism, and oftentimes it just inhibits it. So this causes anorexia, cachexia, different things of the sort. Now, to dive into it a little more specifically, there's specific pathways that have different effects. So this P13K AKT pathway and is an important one. And so specifically when this Y1062 is phosphorylated, it recruits this P13K AKT and it's able to produce nitrous oxide. Now my face is covering that right now, but that's what shows here. And so this nitrous oxide is able to help with the regulation of energy uh, or the homeostasis, I guess, specifically in mitochondria. And so through this pathway, mitochondria is able to be regulated like well, during obesity, I guess, the mitochondria are put into stress. And so they're not able to produce as much as they need. And so they're pushed and pushed and pushed. And this helps to stop that. And this, what really happens in this pathway is it promotes the survival of the cell. It builds up resistance to the stress, to what's going on, and it improves blood flow, um, different things of the sort to really just prevent cell death. These other pathways, this STAT3 pathway, is also very important. Does a couple different things, and so these this Y928 is activated and it is able to, well, I guess it gets phosphorylated and then able to recruit the STAT3. Um, and so what STAT3 is it's a transcription factor. And so what this transcription factor does is it turns on specific genes that promote proliferation, differentiation, and angiogenesis. What proliferation is, it promotes cell growth and regeneration. Differentiation, it uh, makes sure that cells mature into functional cells, and angiogenesis, which it promotes like blood vessels to be formed and promotes blood to flow better throughout the body. And so its general effects, STAT3, this pathway, is to repair tissues and promote vascular growth. However, there's a couple other things that are able to happen. So normally in these high cellular stress situations, growth hormone, this GH, is produced, but sometimes that can be a negative effect, because in areas where like stress or an injury occurs, you don't necessarily want to be pumping a bunch of blood there or pumping a bunch of energy there to be fixing it up because you're just going to be losing it. Um, Different conditions, there are many different things that can happen. However, what GDF15 can do in this case, where this growth hormone is actually uh, bad for the body, it's going to inhibit it. So that's what it shows right here is through this pathway is it's going to be able to inhibit the effects of the growth hormone on the liver. And what that does is it produces IGF-1, and this just helps with the stress response within the body. And so it stops this growth process, allowing for the body to manage this stress. And so it doesn't send all its energy into one place when it might need it many other places. And so, really, through all these different pathways, GDF15 is able to protect cells from apoptosis, stress, and promote growth, promote tissue repair in different locations, and just help protect the body and recover from these different stressors. And you can find my sources right here. But that is this figure. Thank you.